All right, class, so we're back for our third video here in our welding section. And for this particular video, we're going to talk about the oxyacetylene process. So in the first video, we covered a little bit about what welding is. Second video, we talked about oxyacetylene safety, which is very crucial for the processes that we're going to discuss for the remainder of gas welding section here. And so now we're going to talk a little bit more about the oxyacetylene process and how we conduct or perform a weld with that torch process. So when we're talking about oxyacetylene torches, we have to understand that there are two distinct combustion zones. And so when you light up this torch, it'll produce a flame, but there's actually, if you want to think about it, almost like two areas of that flame that we need to focus on. The first of those is the inner cone. And the inner cone is where primary combustion occurs at. So that is the hottest part of the torch. It's a very small area right out of the tip of the torch. Typically it's blue in color, and that's where all the primary combustion happens. So when you're heating up a piece of material, when you're welding a piece of material, when you're cutting a piece of material, you want to put that inner cone right onto the material. Beyond the inner cone, there's an outer cone, a little bit yellower in color. And that outer cone is the secondary combustion area of the torch. So whatever acetylene has not been consumed with the oxygen that is provided will then interact with atmospheric oxygen, and that's where that second combustion occurs. The outer cone does not provide a whole lot of heat. Obviously, don't stick your hand in it because it will burn you. It's still hot. But that outer cone basically creates an umbrella effect around the inner cone, which shields the welding area from other contaminants from the atmosphere. So the chemical reaction for an oxyacetylene torch is we have a hydrocarbon plus pure oxygen, which produces CO2, hydrogen, and hopefully a lot of heat if you have it set correctly. So let's talk about these inner cones, or these cones, a little bit more. So when we look at the cones here, you can see that the first one here is called a neutral flame. Now, before we get to the neutral flame, let me just introduce a little bit of the cones, if you will. So this blue area, the darker blue area there, is the outer cone that shields from atmospheric oxygen. It's just where excess acetylene combusts. And the inner cone is where the 1-to-1 ratio of acetylene and oxygen combusts. That's where the heat is. The hottest part of that torch is on the tip of that lighter blue area. So when you're setting up this torch, you have two dials on the torch handle that you can use to adjust the amount of acetylene and oxygen that's entering that torch. You can think of them as like a fine-tune adjustment on a microscope when you're trying to get it focused. And so what you really want to focus on when you're creating these oxyacetylene torch flames is that we want to use what we call a neutral flame. And the neutral flame burns equal quantities of oxygen and acetylene. And that way we don't have too much carbon or we don't have too much oxygen, and a neutral flame produces the most amount of heat of any other flame setup within the torch. It is preferred when we're welding most metals. As you can see in the image below, a neutral flame does not have what we call the acetylene feather, which means it does not have too much carbon and hydrogen coming out. Okay? A reducing or carbonizing flame is a flame that has excess acetylene, which could result in a little bit of extra carbon being deposited around the weld. So it's used for hardening operations, but it's not good for welding. It does not generate enough heat. And so the acetylene feather is present when we have a carbonizing flame, and this acetylene feather is where the excess acetylene hangs out within the coned area. And so the way that you get rid of this feather is that you either cut back the acetylene, turn down the acetylene knob, or you increase the amount of oxygen. So if you want more heat, you add oxygen to a carbonizing flame. If you want to reduce the heat, you reduce the amount of acetylene being fed to that system. Okay? So if you have to, when you first turn on a torch, you'll see the acetylene feather. You'll dial the torch down or up until you get a neutral flame. The last one here, if you go too far in the other direction, if you add too much oxygen, you get what we call an oxidizing flame, which is a flame that has excess oxygen, which results in an oxygen-rich layer beyond the inner cone. It will take a small pointed area, kind of like you can see at the end of this one here, and turns it into a really, really sharp, narrow point. Okay, it doesn't. No acetylene feather will be present because there's not enough carbon there. But you'll hear the torch pick up a little bit more sound, and it will not produce enough heat. So when you find yourself in one of these situations where you have too much oxygen, you can either dial back the oxygen or you can increase the acetylene depending on what you're trying to do with your heat. So to kind of summarize this all here, we want to weld with a neutral flame. And the way that we adjust the heat of a torch is by the two knobs. Hold on just a second and I'll show you a torch setup. So here I have my torch. Sticks out this way, but here's the torch handle. Here's the two knobs I'm talking about. You see acetylene and oxygen. When I first turn on this torch, I'm going to turn on the acetylene. Turn on the acetylene, I'll light it. Then I'll turn on my oxygen. And what will be coming out of the tip, we want to adjust until we get a neutral flame. If I'm welding and I realize I'm not getting enough heat, I can then add acetylene and then add oxygen. If I am welding and I need to decrease the heat, I decrease the oxygen, and then I decrease the acetylene until the acetylene feather disappears. This will all make more sense once we get to class, but these two adjustments here is how you adjust the flame cone and also how you adjust the heat of the welding process with a torch handle. Okay, hopefully that made sense. Okay, and so here's comparing the flames here. You can see all how that works. Acetylene feather there, no acetylene feather. And then oxidizing flame down here at the bottom. Yeah. All right, let's talk a little bit more about the welding technique itself. So the oxyacetylene welding, there are two different ways that you can do this. You can do what we call a puddle weld and a filler weld. This is also very true with TIG welding, so the same process applies to that as well. Puddle welding is when we use the two pieces of material that are provided, and we only use that material. We don't add any additional weld material, the filler rods, if you will. This requires a joint to fit very tightly and there not to be any gaps between the metal. Okay. Filler welding is when we use this for more pore-fitting joints or when we want to add additional metal to the joint or the gap. Typically, it's the filler material should have the same composition as the base material. Base material referring to the piece of metals that we're welding together. Sometimes it can look like copper. It might have a brown coating, but inside of that coating there is pure filler material weldment. So that's the basic thing. You can either puddle or you can filler. Puddle welding is easier in my opinion. Filler welding does take a little bit more practice. But you will have a chance, and you'll have to do both when you're doing your TIG welding coming up in the shop. When you're welding, you also can choose whether you do what we call push or pull the puddle. So what happens here is when you melt that material, the first thing you want to do when you're welding is you want to melt the material and it will form a molten puddle. You can either push that puddle down the joint or you can pull that puddle down the joint. So we'll talk about pushing first. Forehand welding is oftentimes called push the puddle, and the flame is pushed across the joint. The thing about forehand welding is it is often used on relatively thin materials because it produces a lighter penetration. Mainly the heat source doesn't focus on that metal as long as you're pushing. If you're pulling, the heat tends to focus and push the puddle deeper into the metal. So it provides really good control of puddle, and it cools relatively quickly. That's why it doesn't penetrate as deep. Forehand welding is probably the best option for welding thinner sheet metal materials. You can see here that you have the torch tip and you have the welding rod being dipped into the puddle. That is called filler welding. Backhand welding is the opposite. We pull the puddle down the joint. It's used on thicker materials. It does provide a deeper penetration. You can see the difference in the picture there below. All right, so our last video, we will talk about mechanical bonding techniques of brazing and soldering. Will come up in a minute. Hopefully you all got a good feel there of oxyacetylene processes and how we weld with it. Again, we will not be doing oxyacetylene welding in our shop this semester, but you will be using an oxyacetylene torch, as you'll learn about here in just a minute.